about area under a curve. Today we're going to look at what if we have more than one function graph and finding the area between the two curves. So this is going to allow us to compute areas of complex regions of the plane. Later in the week, we'll be able to compute volumes of complex regions. We'll see if we get to that this week or if it's next week. I feel like the hope of us having a test before spring break is dwindling quickly, but not yay, because that means you're going to have a whole week off and come back to test. So it's way better to have the test before spring break than to have to push it back and have a week off.
We can use that AP test so we get
No. That's another grade on top of that. So the good news for you is I made this, I was going to make you write all these, but what am I doing? Why did I not make you write all these? If I do these two functions here, if this was f of x and this was g of x, and I bounded them between a and b, do you agree if I took the integral of f of x, that would give me the area all the way to the x-axis, yes?
Yes.
If I took the area, or the integral of g of x from a to b, that would give me the area from here to here, like the white spot. So if I wanted to find the area between the two curves, does it make sense that we would take the area of f of x minus the area of g of x, right? So that's really all the thing is. We kind of did that already, which means, look, I wrote all this out for you. If the area under f means the integral from a to b of f of x minus the integral from a to b of g of x. But if you wanted to, you can just do that all at once. The area between two curves is defined as the integral from a to b of f of x minus g of x. Order matters here, though, right? The taller function, the function that's above, has to be on top because you're subtracting. So if you do it the other way, then you're going to get the wrong answer. You're going to get the negative answer. So you must determine which one's bigger, either by graphing it or just by, we'll talk about other ways we can do it besides graphing. But that's not so bad. I do want you doing most of these by hand today, though, because they're not bad to integrate. Good practice. So here we go. Find the area of the region bounded by f of x equals x squared plus 5 and g of x equals negative 5x minus 6, where x equals 1 and x equals 2. Analytically means not using F9 or Math 9 or whatever it is. So I'm going to sketch a rough graph of this. It doesn't have to be perfect. You're welcome to use your calculator to guide you as you check your answers, but don't be relying on your calculator so much on stuff like a quadratic and a linear equation. Notice that they tell you x equals 1 and x equals 2. If they don't give you the bounds, that means they must intersect nice enough that you can find those bounds by yourself. So why am I making so many lines on here? But that's okay. I really only need 1 to 2, right? If I plug 2 in there for x on f of x, that's going to be what? 9? So I think I need to go to 9 here. You should know that x squared plus 5 is just a lovely parabola that's moved up 5, because if I plug in 0, then I get 5. If I plug in 1, I would get 6. If I plug in 2, I would get 9. And I like graphing it at first so you can visualize this, but eventually you don't have to graph everything. But I'm not going to even graph the other side because I don't really care, except for I care what's happening between 1 and 2, because that's where I'm trying to find the area. What about this one? Negative 5x minus 6. Can I make a worse problem here? That has a y-intercept of negative 6. And a slope of negative 5. Gross. All right, I'm just going to get rough here, all right? 1, 2, 3, 4, 5. If I go down 5, I would go this way, right? Or I could, no, just kidding. If I go down 5, I would go this way. This is terrible, kids. Roughly, like that? So you might say, what am I finding the area of? That's where this part is really important. X equals 1 and x equals 2. This would be the area that I'm finding. Not really, because the top's curvy, right? If you can tell that this one is definitely going to be above this one without graphing it, you don't have to make the graph every time. I like to make the graph today because it's day 1 and I like you to see it. But just so you know, the graph is not required. What's required is to know, oh, I'm just going to integrate this from the bounds that they gave me, which is 1 to 2, and I'm just going to take the bigger function, the top function minus the bottom function. So I'm going to take x squared plus 5 minus the bottom function, and this is where you got to be careful. I'm going to go ahead and distribute that negative and say that's going to become plus 5x plus 6 dx. And if I integrate that function correctly, it's minus, right? Like it should be here, f of x minus g of x. I just distributed. And you can integrate right now if you want, but why integrate extra stuff you don't have to? Like I always combine like terms if I can. So like I'm going to write that as x squared plus 5x plus 11. Also, I can't help myself but write it in descending order. But if you integrate this top function, you're going to get the same answer. You've just had an extra term, right? You see what I'm saying there? And so then this is where you just get to have lots of fun integrating. So I'm going to say x cubed over 3 plus 5x squared over 2 plus 11x from 1 to 2. Watch your negative signs here. If I plug a 2 in there, I'm going to get 8/3 plus 10, is that right? 4 times 5 is 20. 10 plus 22 minus 1/3 plus 5 halves plus 11. This is where I really enjoy having 0 as a bound, because usually the other one always goes to 0. Remember, if this were a no calculator part of a test, a free response part of the test, you could stop right here, right? And so this is where I like to see some work, all right? I want to see that you know how to do the calculus. I want to see that you did some work by hand. I want to see you didn't use Math 9. But from this step, by all means, type it in your calculator. And hit Math 9, or no, hit Math 1, because it'll change that decimal to a fraction if it is decimal. What? No, decimals are never better in calculus, unless it doesn't equal a fraction. That's the only time. Notice I put the big minus out front, and then hit Math 1, and that will change that to a fraction. I got 125 over 6. Did you get 125 over 6? And you're going to get some weird answers on these fractions, all right? And the super great thing about your calculator is it gives you the improper fraction, which is what we want. We hate mixed numbers. I don't know why they ever teach mixed numbers. The only time mixed numbers are useful is when you're cooking. And that's only because your measuring cups don't come in improper fractions. But that's the only time, right? In math, we like improper fractions. Let's do another one. Don't you wish someday I just tossed, like I just gave up and I was like, ah, no more time. I always think there's more time. I just want to at least show you this one so then we can pick out which problems we can do. Notice on this one, they don't give you like when x equals 1, when x equals 2. That means we have to figure out where these two intersect each other, which we can do with algebra, or we can do by making a really nice graph. You can use your calculator to help you. But, again, let's try without a calculator first. X squared minus 1. Can you make a nice graph of that? What's that look like? A parabola. You can just pick some points if you want, but that's moved down 1. So when I plug in 0, I get negative 1. Just move down 1. So when you plug in 1, you get 1 and 1. What? The next one would be 3. And it would look something like this. And then x plus 1, that's better than my negative 5x minus 6. That's just slope-intercept form. Y-intercept of 1, slope of 1, so up 1, over 1, up 1, over 1, down 1, back 1. The area is where those two curves intersect, like the closed figure that's made. Do you see the closed figure that's made in there? This is the area that I'm finding. Do you see that? else is open. So that's how you know where your area is. Can you tell from the graph where those intersect? -1 and 2, that's what it looks like for me. If you didn't know, or let's say you didn't graph it, could you use algebra to see where those intersect? Could you set these equal to each other and just solve it? You'd end up factoring, and you could also get your solutions from there if you're not sure. But you got to find the points of intersection if they don't give it to you, and which function goes on top this time? Yeah, the x plus 1 is first, so it's going to be x plus 1 minus this, so I'm going to go ahead and distribute and say that's minus x squared, and that's going to change to plus 1. And again, it's up to you on how you want to do this. I just tend to always switch it around, so I'm going to put negative x squared plus x plus 2. Some people never simplify, like they always just integrate what's there, and that's okay. I just think it's more steps, so I don't like to do that. The basic idea makes sense on this. Graph them, see which one's on top. If they don't give you bounds, you have to find the bounds. See which one's greater, I guess, is what we're looking for. And then it's just the fun part of integrating now, right? I feel like we should have like board races for integration. It's so much fun. Negative x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 2. And really, if you're going to use your calculator, I'm totally okay with you just writing 4 over 2 here. Like, it doesn't matter. I'm going to go ahead and simplify it, but don't feel like you have to. Minus, I like my parenthesis here because there's a lot of negatives going on. And I'm plugging in a -1 and I'm subtracting. So I'm going to leave my minus sign out there, and that's going to become positive 1/3. Is that true? Because it's going to be negative and then a negative, and then that's going to become plus 1/2 minus 2. Tell me if you disagree. And really, something like that, I could make you do without a calculator, but why when you have one, right? And then if I just leave my negative and I just use parentheses on my calculator. But I do want to see that work. Like, even on the test, if I say you could use a calculator but show work on this, oh, that's just 9/2. Did you get 9/2? 9/2. Okay, where we'll start tomorrow is what happens if it's in terms of y, and that's where the notes leave off, and you're welcome to look ahead of that if you want. What if instead of top to bottom, you're looking at like side to side, and so we have to look at it in terms of y and our bounds in terms of y. We haven't really done that before. It's the same idea, and so we'll start with that tomorrow. Feel free to look at those, but let's see which problems on the homework you can do. 8. What time did we get up here? 13? All right, sorry. Go to this one first. Number 4. We can get that one done. It's a calculator question. It says, use a calculator to find the area of the region enclosed by the graphs of the two functions. Which means if you can use a calculator, then you can graph these on the calculator to see which one is the bigger function, right? So, first of all, you need to go and turn your stat plot off. And then you need to graph these, probably change your bounds. But I didn't leave mine open. So my goal every day just to make you have to wake up and celebrate. Go back to where you were. Stat plot and turn it off. Second y equals, and it should say on right now. You hit enter and go over and turn it off. Like it should highlight off. And then we're going to graph, what are we graphing? Cosine 2x. 2 cosine of x. And what else are we graphing? X squared minus 1. X squared minus 1. Oh, that's not right. Oh my gosh. I've never said how much I hate this calculator. Minus 1. Our window's really weird too, right? So let's go to window and let's just do, I'm just going to do zoom standard actually. I'm going to do zoom number 6 and see what happens. It should graph a lovely cosine. Oh, it's so nice. It's sure to graph way faster than mine. And then x squared minus 1. Do you see the shape in there that we're going to find the area of? Do those intersect at nice points? I don't think so, which means this is why it says use your calculator. We can definitely see that our integral is going to have cosine on top, so we know we're going to take cosine of 2x, right? Is that what it was, or 2 cosine of x? Goodness gracious. We're going to take 2 cosine of x minus the x squared minus 1, which is going to become plus 1. But we got to find our bounds, and that's where the calculator comes into play also, because we can find the intersection point. If you hit calc, second calc, number 5 is intersect, and it's always going to ask you which 2 curves, first curve, second curve. If you only have 2 curves, just hit enter. Enter, it'll jump to the second curve, enter. And then it wants you to guess, because as you can see, there's more than one intersection point. So you want to go positive or negative here? I'm just going to go negative. And hit enter. Oh, look, it told me already. Did it tell me already? And it told me that the intersection point is negative 1.265 to 6.1. Which one do I need, the x or the y? The x. So I'm going to write negative 1.265424. Use all the decimals they give you. Because you found this one over here. Because you just randomly, you didn't guess. So it picked the closer one, right? So you need to get close to it when there's more than one. Because these are both symmetric curves with the y-axis, they're even. Do we agree that this one's just going to be that same positive number? You could do it and check if you aren't sure, but this is just going to be positive 1.265424. That's a lot to type in your calculator, but if you just stop at 1.26, you might not get the same answer that the answer key has, and so that's why you want to use all the decimals. So the idea is when they give you a calculator, you don't have to integrate any of this by hand, but you need to know how to do it on your calculator. So now you're going to hit your Math 9, and you're going to type all that in, and then you're going to hit comma x and comma all that. All right, I have to see what homework we can do, so don't leave. I really should just make you figure out what homework you can do, right?
Yeah, you should definitely.
3.
I just want students' office, please. I need Zebediah Bowles,
I'm going to just say ones you can't do, okay?
Nicholas Thompson, Montana Huber, Dylan Phillips, Drew Steffi, Kate
10
Switzer,
is maybe, depends on how you do it, right? So I'm going to put question mark on 10. Because I would do 10 a different way.
Morgan
You can do it
Akers,
that.
the office, please. I
Um,
have just a reminder, tomorrow morning at 8 a.m. is student council meeting.
15 I think you can
Tomorrow
do.
morning, 8 a.m. is student council meeting.
16 I think you can do. I think you can do most of these kids. Yeah, not 52. So you could throw 10 in there too, or you can try 10, all right? But the rest of those you should be able to do. Look at the graphs. Some of them they give you graphs. Try to check.
Harry Cassidy Grace to the office, please.
Say that again. Oh yeah, that's fine. What is it? Like the 26? Is that what you mean? You just part A we did already. Like we did it on the board earlier. It was just like that 796 something. Like, that's all you have to write. 796 point something. And then you're done with it. Don't worry about it. Don't worry about it.